Hello, I'm Kevin Svetana. I am a professor at Audubon University in the Department of Biology and Earth Sciences, and I'm also a senior project manager for BSI Consulting Services. I'm a certified professional in the Ohio Voluntary Action Program, which is their Brownfield restoration program, and I'm also a licensed professional geologist in other states. Today's talk is about brownfield restoration, also known as land recycling, and we're going to focus particularly on uh, efforts to take brownfields and put them back into natural states, something that is more conducive to a natural environment. So, with that said, let's get started. So, what are brownfields? Let's start with the definition provided by US EPA. They're abandoned, idled, or underused industrial or commercial sites where expansion or redevelopment is complicated by real or, emphasis, perceived environmental contamination that can add cost, time, or uncertainty to a redevelopment project. Most brownfields are remnants of factory closures or failed businesses or obsolete products, those type of issues. And most of these properties are connected to the development of the environmental regulations that was initiated in the mid 1970s. And these became an unintended consequence or byproduct of the environmental regulations. In Ohio, it's not hard to find a number of brownfields in almost any community. And really, what has caused this abundance of brownfields was the development of technologies post World War II, primarily the electrochemistry and synthetic chemicals industry, although manufacturing also contributed to this as well. And the environmental awareness, which was initiated and actually brought to the public forefront by Rachel Carson's book Silent Spring in 1962, made the public more aware of the impact of the chemicals that essentially were being developed to make our lives better, but also having an impact on nature. So, as I said earlier, in the 1970s, there were quite a few environmental regulations on the federal level that were initiated. Probably one of the most recognized is the Comprehensive Environmental Restoration, Compensation, and Liability Act, also known as CERCLA or Superfund, which was initiated in 1980 and then upgraded several times after that. It basically looked at the risk of environmental impacts to the public primarily, and then later on more so to the environment itself, the ecological environment. And it gave the ability of the federal government to come in and clean up sites and then hold responsible parties accountable for it. And since this was a very new approach, there was a lot of vagueness in the environmental laws and policies. There was a precedent of enforcement then on lending agencies and landowners, regardless of their contribution to pollution. And from those, a lot of people abandoned sites. So, the public fear regarding pollution, the unknown of that. And there really was no voluntary program to allow people to go in and do cleanups and have an agreement, from the state agencies or the federal government to basically say that the risk had been mitigated and the risk to the public was no longer unacceptable. So in the 1990s, mid 1990s, states were advised to come up with their own voluntary cleanup programs. In Ohio, it's known as the Ohio Voluntary Action Program. In Ohio, certified professionals actually lead the program. So these would be people who don't work directly for the state, but are essentially licensed by the state. To give you a sense of the problem related to brownfields, I'm going to go to Johnstown, Pennsylvania, and look at specifically the Bethlehem Steel. Bethlehem Steel was a major steel producing company from the essentially the late 1800s up until the 1990s. And this particular Bethlehem Steel facility in Johnstown is kind of unique because it helps demonstrate what happens when brownfields evolve. So Bethlehem Steel went out of business several decades ago, and in Johnstown, they were a major employer. They employed thousands of individuals. And as you can see, Johnstown has kind of a unique geography in it. The floodplains, the river valleys, are the flattest areas and probably the most valuable real estate because Johnstown exists in these steep rolling hills, and really, the best place to have a large footprint for a large factory is going to be in those floodplains. And that's what you can see. I mean, here's a close-up of a portion of the facility, but here's the layout of the facility, and you can see the surrounding community. And this used to generate revenue from a tax standpoint for, from thousands of workers who were there. And when Bethlehem Steel went out of business, essentially they left the infrastructure behind. And because of asbestos and contamination, there's really been no interest in redevelopment. So it sits idle. And as it sits idle, it deteriorates. And as it deteriorates, it goes from becoming an asset to a liability. And as you can see, in the last 25 years, nothing much has changed. These Google Earth images here, I mean, there's the facility as we see it from that air photo. And then here's a 2019 image. And you can see not a lot has really changed to improve, the lay of the land or incentivize new people taking over. So in essence, you have a large area that used to be a source of income for the city is now sitting idle and eventually going to become a problem that has to be dealt with because at some point in time it will become a public nuisance and a risk. Brownfield problems are complex, and just from looking at that Johnstown issue, you can see that it takes a team of people to really solve the problems. And this has to be a multidisciplinary team. And it's very common for the larger projects to need chemists and the skills of toxicologists, geologists, soil scientists, biologists, economic specialists, engineers, planners, and regulatory specialists, all working in concert to try to solve the problem and take the land from underused and blighted to something that could be more beneficial. So what is it that this team of experts have to actually evaluate? So let's look at an overview of the evaluation of a brownfield site. So some of the first things that you have to understand is the type of contaminants, and then specifically looking at the dose and toxicity, and I'll get into the definition of these in a few minutes. And then we also need to look at the mobility of the contaminants, which we refer to as the fate and transport, how they move in the subsurface and how long they persist in the subsurface. And then the next part is looking at a model of the exposure pathways. How does it get to where the chemical was released, to where somebody or an ecological environment could be affected by this particular chemical and the path that it actually takes to get there. And then part of the solution is eliminating the pathways, which we'll look at some of the ways of doing that, actually destroying the chemicals or using engineering controls as a way of creating a barrier to prevent the receptors from actually being exposed to the chemicals. And a lot of this takes imagination. It takes trying to envision what a site can be. When you're looking at an old, dilapidated, rusting, falling down buildings, a a property that's in disrepair, trying to look at that and think, what could this be? How could we improve that? And a lot of times that's really part of the challenge, because that drives the prior bullets listed on this page in trying to understand the total system and how to make it safer. So let's drill down into the discussion. Let's first focus on toxins. Okay, they're all around us, and one of the things that really is the critical factor to understand is basically dose and toxicity. So one of the first things I have listed here is a sodium monofluorophosphate. And you say, what's that? Well, if your toothpaste has fluoride in it, that is what sodium monofluorophosphate is. And most people wouldn't think, well, toothpaste, that couldn't be toxic. Well, if you consume too much, then yes, it actually could be toxic. And if you look at the labeling on like children's toothpaste, I mean, it has an advisory there for the consumption. Another one that I have on this is a product known as coal tar. Okay, and coal tar was a byproduct of burning actually wood and coal. And I have this young man here who's a chimney sweep. And the reason I put this photo in is this is kind of a connection. This is one of the first connections between occupational risk and cancers. The young gentleman here was, cleaning chimneys, probably crawling down in through the chimneys to do the cleaning. That would probably be an efficient way to do it. They typically would have children do this just because they're smaller, they fit easier. And then, they get the coal tar, which is the residual material that they're trying to clean out of the chimneys, because if the chimney gets hot enough and there's enough buildup of coal tar, it could actually catch on fire and cause a house fire. So that's why the chimney sweeps were important in the 1800s. In fact, people still have chimney sweeps today if you have a wood-burning fireplace. But anyway, this was one of the first connections, because most of the people who would do chimney sweeping would end up developing skin cancer from the exposure to the coal tars, okay, to the compounds in the phenolic compounds in the coal tars. And this is one of the first, if you look up the literature, this is one of the first connections between someone's occupation, the risk from chemical exposure, and a life-threatening situation, which would be the skin cancers. So, but here's a product, this shampoo, much like the toothpaste, that we know exists and, are used. And literally the coal tar in the shampoo will kill the bacteria and the yeast on the skin that will cause the dandruff and the inflammation that people are trying to control. But it's by applying it at an appropriate dose, you're not being exposed to the toxicity of that product. Likewise, Roundup is in the news now because of class action lawsuits of exposures and a link to cancer. So, again, this is another one of those, if you're using it correctly, you shouldn't have an issue with it. But again, they're looking at Roundup and rethinking how innocuous it may have been in our environment, and whether or not, that was something we didn't understand well enough. So I have the examples here of caffeinated drinks. It comes down to dose and toxicity. If you start knocking back about 6 or 7 of these energy drinks, it's equivalent of having 6 or 7 cups of coffee. And some of you probably are familiar with what happens when you have too much coffee. You start getting jittery. You start losing your focus. Again, we're kind of getting back to that dose and toxicity. And not all doses and toxicity are equivalent. That's why I put the tea here. Tea typically has less caffeine than a caffeinated soda or a cup of coffee. So, but it's understanding that relationship between dose and toxicity that's the important first step of trying to work with these Brownfield programs. So just to summarize the information I put out in that last slide, dose is the amount of a chemical or compound related to an exposure. And then toxicity is the measure of a chemical or compound's potential for causing harm or death, the lethal dose to the 50%. And that's basically how it's measured. You expose a population to a dose, and if it will kill 50% of that population, this is usually done on laboratory rats, that's known as the LD50, and that's essentially a threshold for toxicity. Pathway, again, is that route of exposure. How does it get from where the chemical originates to where it actually becomes an exposure, okay, where the dose is applied? And the receptor is that endpoint of the exposure pathway. So a receptor can be mostly, its focus is on humans, but it also looks at biota. You know, it looks at fish, it looks at birds, and so on and so forth. And then how do we find out about these? You know, if you're an ordinary citizen, not doing this type of work on a regular basis, how do you find out about it? Well, there are safety data sheets. And by federal law, every chemical produced has to have a safety data sheet available so that you could actually look up and read about the toxicity and the exposure potentials and so on. And these are available. In fact, if you go to Home Depot and buy paint and ask them for the safety data sheet, by law, they have to provide you that safety data sheet, which would describe, you know, your exposure risk associated with that particular product. And of course, there is a subset of the Centers for Disease Control known as the Agency for Toxic Substances and Disease Registry and Toxicological Profiles, the ATSDR. They actually maintain the toxicological profile. So if you bring a product to the marketplace, you have to go through this testing and basically disclose this material. And this is the federal agency that's responsible for that. So let's talk a little bit about fate and transport. So this is the original site conceptual model that was in the ATSDR publication back in the 1980s when people were starting to work with pollution abatement. And what this does is basically shows, you know, a very important part of any site is coming up with this conceptual site model. And regulatory agencies like Ohio EPA or US EPA usually like these to be put in a cartoon format so it's easier to understand rather than getting into detailed geologic cross sections and soil profiles and so on and so forth. They like it this way so the story can be more easily told. And let me just kind of walk through this one to give you a sense. So if we have some chemicals released here, and I'll use my term methyl ethyl offal, so for a generic chemical. But let's assume that this chemical behaves somewhat like gasoline, where it can be a liquid, it can evaporate rather easily on a warm day and become a gas, and it can actually infiltrate the soils and go into the subsurface, where it can also act and travel as a gas or travel as a liquid to the water table. So if we're thinking about exposure, you know, this individual has a potential for an exposure. And if we look at it, you know, the individual could be standing close enough to smell the chemical, so that would be an inhalation exposure. If they were curious and put their hand into it, it would be a direct contact. And maybe if they were even more curious and put their hand in their mouth, then that would be an ingestion. So it would be these three exposure routes: ingestion, inhalation, direct contact. So that would be the potential risk in this scenario. Now, if the chemical makes its way to the subsurface, becomes entwined with the groundwater and mixes with the groundwater and then comes to this well where it's pulled into the house, this individual would also have those three exposure routes. They would have ingestion from drinking the water, inhalation from when the water's running, it could actually, the gas, because it's volatile, would off-gas into the house, so there'd be an inhalation. And if they're using this to shower or wash their hands, a direct contact as well. So you can see, you know, this is a pathway, a transport pathway that gets it to somebody that's not directly related to or directly next to the release area. And then if we look at these individuals, you know, their risk may be less because they may only be exposed to the vapors that are essentially wafting on the wind. Likewise, they have the cow here. And the cow could actually eat the crops. That could also uptake some of the chemical. The cow then could actually have the milk from the cow. Then that would get into the humans, and you get a sense of the fate and transport here. So this is part of the initial steps, is to try to figure out where's the risk, how is the risk going to move, and who could be affected by this risk. Another key part when you're doing the fate and transport is understanding the chemical characteristics of the contaminants. So some of the things you need to understand: what's the phase? Is it solid, liquid, gas? And like the example that I had in the last slide, we can see how the liquid actually can transform to a gas. Or let's think of salt being thrown down, on sidewalks. And it's a solid, but then when things warm up and you get a rainfall, well, then it all dissolves off and becomes a liquid. It actually becomes dissolved in the rainwater and the runoff, and it essentially is a solution of salt water then. So you can see how phases can change. And then the solubility. Does it readily mix like the salt example, or is it more like gasoline where it's only going to be partially soluble? And then the density. Will this chemical float on the river or float on the groundwater, or will it actually sink because it's heavier than water? And then absorbance. Does it preferentially stick to things, or doesn't it? And that all affects how long something will stay in the environment. And then the half-life. We have chemicals like benzene, which is a component of gasoline, which has a relatively short half-life. It doesn't last long in a natural environment. It's readily broken down by a multitude of things, including bacteria. And then we have things like PCBs that have very long half-lives, are very stable and very not prone to break down. So let me briefly touch on some of the chemical characteristics that affect that fate and transport. So for this, I'm going to talk about L-NAPL, D-NAPL, and partial solubility. So L-NAPL is a light non-aqueous phase liquid. And I mentioned gasoline, and gasoline is an example of an L-NAPL. The gasoline would actually float, would sink through the unsaturated soil and then float on the water table and remain in the upper portion of the water table, where a dense non-aqueous phase liquid, like a trichloroethylene or perchloroethylene, would be the opposite. Because it's heavier than water, it would move through the unsaturated zone, get to the water table, and then continue to move downward. So from a remediation standpoint, these ones are a little easier to deal with because they tend to stay in the top of the water table. They tend to break down easily. These ones are a lot harder because they move into the subsurface where it's difficult to locate them, particularly if the geology becomes complex, and they're much more persistent than a compound like benzene. And what happens if we look at the microscale, a little bit of these chemicals absorbs to the individual grains of soil, and as the groundwater flows through the grains of soil, it dissolves away a little at a time. And why is that important? Well, that relates to partial solubility, very low solubility of compounds. So again, I'm going to look at benzene, which is a component of gasoline, and it has a solubility of 1,750 milligrams per liter, which is not a lot, okay? But the maximum contaminant level, the allowable concentration of benzene in drinking water supplies, is 0.005 milligrams per liter. So you can see a little bit of residual dissolving away can actually create, because it's going to be closer to the 1,750, and that's going to be orders of magnitude greater than the drinking water standard. So you get a sense of the risk involved with even small amounts of these materials. Okay, so now let's take a look at how a voluntary cleanup would work in the state of Ohio. As I said earlier, the federal government basically passed down Brownfield voluntary cleanups to the state level, and the states had to come up with their own programs. And Ohio is a little bit unique. It's one of a few states that actually allows certified professionals to drive the actual investigation and cleanup work under the Ohio Administrative Code 3745, Section 300. And the state licensed certified professionals, or CPs, and these folks have the authority to basically manage, supervise, and certify that sites are cleaned up to the state standard, and they can do this independently, concurrently with Ohio EPA, or in some cases they can actually involve the federal government, state government, in the agreement, and that's a memorandum of understanding that basically says at a federal and state level what the certified professional has supervised and implemented is acceptable and protective of the public. And in conjunction with that, laboratories who do the work, the actual analytical work, are also certified by the state of Ohio under the voluntary or VAP program, VAP program. So how do you go about evaluating a brownfield site? The first step in the process is basically a phase one. It's a records review. It requires the certified professional or people on the certified professional's team to actually visit the site and basically look and see, what the potential for the risk is. And by the records review, you're trying to get a sense of what was done there. Was this a dry cleaner and a strip mall, or was this a manufacturing facility that produced chemicals? And if it produced chemicals, what type of chemicals? So you're trying to get a sense of, is there a potential for a risk, and if there is a potential for a risk, do you need to essentially take it to a phase two? Now, if a property was undeveloped, a standing wood lot, or possibly a farm, you may end your investigation at a phase one. There may be no reason to move forward because it just doesn't have a credible risk. However, if the risk is identified, then you go to a phase two. And this is where you actually start collecting samples and assessing the results of doing laboratory analysis of the samples to basically try to delineate and see how the concentrations of potential contaminants match up to the standards that exist in the regulations, the 3745-300 code regulations. And then once you identify what the types of contaminants are, you're going to look at dose and toxicity, where your risk is exceeded. You're going to look at the potential mobility. How's it going to move in that fate and transport? Where are the potential exposure pathways? Is it in soil only? Is it in soil making its way to groundwater? Is the groundwater making it to a surface water? All of that has to be put together. And then you start looking at how you can break those pathways, and that's where you start looking and thinking about your engineering controls. And again, going back to what I said earlier, this is where you want to try to envision what the site can become. What is a potential development? Now, I didn't talk about in the earlier slide, there's essentially 3 levels, there's actually some sub-levels there too of cleanup. But essentially there are 3 levels. One is residential, and that is the most rigorous cleanup because that one assumes that you'll have young children 24/7, at the property. So it's essentially a home scenario. Then you have commercial, which means that people are typically there a limited number of hours per day. They're not spending, it's not a 24-hour exposure calculation, and they're predominantly going to be adults, although you have to also consider whether or not children are going to be in part of that exposure scenario. And then you have industrial, where you're basically looking at, children won't be there because it's an industrial facility. It is going to be adults. And I will also add to it is, protecting children, because growing children are the ones that are most risk, particularly for exposure to toxic chemicals. So that's why, they're the most sensitive, and then the industrial is going to be the least sensitive. And in this talk, since we're focusing on nature and people being out in nature, we also want to consider another category which Ohio EPA has developed and has used in multiple locations, which is a recreational. And that's how you can take an old industrial site and actually bring it forward and get it to be a recreational park or metro park or something like that, which we'll get into here in a bit. So once you have defined what impacts have occurred at a site and you know the fate and transport model, the next part of it is to try to correct that. And correcting that can be as simple as trying to remove all the contaminants. However, this may be cost prohibitive if the contaminants are deep and difficult to get to, and you basically know that they're not going to directly affect a receptor. Then sometimes letting some contaminants or residual contaminants on site is okay. And but sometimes that requires you to restrict site activities. Like if the groundwater has chemicals in it, then we're going to restrict that nobody drinks that groundwater on it. And the other part is to isolate the contamination. And this can take literally years of effort. Some of the things that are going on in the photos here, this is actually a chemical treatment of groundwater where they're actually putting chemicals in to break down specific contaminants. This is an oil recovery using sorbents to draw off released oil that's accumulated in the groundwater. And then here's a tank farm that's being taken out of service, and basically reclaiming the metals from the tank farm, and then they're going to come in and clean up the soils and work as well on trying to clean up the groundwater. And these efforts can take years to maybe as many as decades to actually bring the effect that you want in terms of cleanup and remediation. Ohio's Brownfield program has been in effect since the mid-1990s, and there are a lot of successes. And just to go through and look at some of the ones here in the central Ohio area, Miranova is an apartment complex in downtown Columbus, and it's built on contaminated soils where the garage and the first floor have specific uses there that protect the residents that live in the upper floors. So that's an example of an engineering control. Another would be another familiar site is the Smith Brothers Hardware building. And if you're driving in 670 coming into downtown, most people see this building. This is another brownfield where the asbestos that remained in this old warehouse and some of the chemicals spilled at the warehouse created a problem. And then the Jeffrey mining area here, which is being redeveloped now. This is an older photo, and there's actually more buildings that have been placed because this one has slowly been being put back into use, and a little more challenging. This one had a lot more problems with tunnels and whatnot at the site. So if we move on, the Columbus Convention Center. That was an old CSX rail yard. It was built over top of a rail yard. So again, remediation was done so that the convention center could be built there. And then we have actually two of them now. We have the original Crew Stadium here in the background. You can see the light standards. This used to be Columbus Auto Parts, and it's now the site of the Lowe's, where here's another example of an engineering control. The parking lot essentially protects people from contaminated soils that have very low migration potential, and as part of the remediation, this is inspected. This parking lot is inspected on an annual basis, and that's reported back to Ohio EPA that it's in good shape and it's providing the level of protection. And likewise, the new Crew Stadium, which as I'm recording this, just opened up and had their first game. And it also was built on the former Jaeger tool site. That was another brownfield property. So, here's Huntington Park where the Clippers play, and then this is where the new stadium, the lower.com, I guess is the name of it. And that also is a brownfield redevelopment site. So, and next to Huntington Park, Huntington Park had some brownfield issues there. They had some cleanup there that was done before the baseball stadium went in. And close to it is Promo West, an outdoor concert venue. And again, there was cleanup work done on that in order to get it to where, it would be safe for the concert venue. And of course, there's a lot of brownfield in the Arena District of Columbus. This is the home of the Blue Jackets, the NHL team, and the problem. This property here was the old Moline Plow building. That one was a brownfield redevelopment. Some of the property here where Nationwide Arena is, and some of the adjoining properties were all brownfield cleanups to basically revitalize, which was a part of Columbus that was very much underutilized in the 1980s and early 90s. So I've provided examples of development where they were put into commercial types of redevelopment here, the sports fields, the shopping centers, and so on. But this particular conference is more about getting outdoors. So I want to focus now for the rest of the talk on Whittier Peninsula, which was a part of Columbus that was very underutilized. And just to give you a sense of where we are, here's the downtown area of Columbus, the state capitol buildings in this complex here. And Whittier Peninsula was this area that essentially was a landfill in the early 1900s, and then it became the impound lot for the city of Columbus. This particular photo, you can see all the cars that have been towed, for whatever reason, and this is the impound lot where they would be held. And then there was an old warehouse here and some old factories in this general area. And I was involved in this project in the early 2000s. When the city was looking to maybe develop this, to use Clean Ohio funds to possibly redevelop this and make it riverfront housing, kind of expand the housing area here, when Mayor Coleman was trying to revitalize downtown Columbus and make downtown Columbus a little more livable. So let me go through and talk a little more about the history of this particular site. So here is a Google Earth image from 1994, and you can see, this is pretty much undeveloped. The main activity here is the impound lot. The city owns, this used to be Lazarus Warehouse there, and then the city ended up acquiring it, and they were using it for the school districts, to store school materials, but the building went into disrepair, the roof collapsed, etc. And this is a warehouse that part of it is still there and kind of repurposed, but it was a large warehouse, and then those smaller businesses were in there as well. And this was in an era when we're trying to put more residential housing in downtown Columbus. And the true downtown is just where I'm showing on the cursor here, and this would be a walking distance. So when it was determined that most of this property here was all landfill and couldn't be built on because of unstable soils and whatnot, the whole housing idea kind of fell through. And the city now had to start thinking about, what's another alternative use? So let's talk a little more about what was there. At one point in the late 1800s, the Ohio Hocking Railroad, the terminus of that railroad line, was in this area along where the existing rail lines are. Then it was also the city dump. There was a concrete plant there. There was a small petroleum storage facility with some bulk tankage that in that 1994 photo was they were already gone. The warehousing was there, the city's impound lot, and a few small manufacturing facilities. So here are some photographs of what was there. I mean, this is the impound lot outlined in red, and you get a sense. I mean, some of these were vandalized or damaged to vehicles. Some of them were just towed because they were illegally parked. And this is basically if you parked at Ohio State and got towed because you parked in the wrong lot, this is where your car would end up. And the facility was heavily policed and whatnot. This is an image showing the warehouse. This was originally owned by the Lazarus, which is now part of Macy's, but it was the old Lazarus, the downtown department store. You can see here's the front of it. This is the inside. These are not skylights. They are literally holes in the ceiling, and you can see it was lighting up. At this point, when this photo was taken, most of the material was taken out. And then there were some other manufacturing facilities, smaller buildings that didn't have quite the footprint of the Lazarus warehouse. And they were left like this. And you can see, there's probably chemical releases related to these drums being tipped over or this debris just being scattered throughout the property. Also, there were a lot of homeless folks that this was where they lived. I remember when I worked down there, this was a gentleman's house. He had his mail delivered there. He had a dog, a friendly dog. It was very common to see abandoned vehicles in the area. There was a lot of dumping there, people just taking trash, old couches, things like that down and just getting rid of them. The vandalism, the tagging and the graffiti. There was a lot of prostitution going on down there, and there was also quite a bit of issue with drug abuse and drug sales. It was not a very good area. In fact, there were over 400 homeless people who they had to find alternative spaces for them as they started doing the development of this property. So I want to go back to a point I had in an earlier slide about the vision. When Mayor Coleman's group realized that this couldn't be a housing development, they wanted to see something else happen. And part of the vision, folks who are birders know that this is on the flyway, the North American flyway. And actually the cemetery to the west and the sports parks, the softball fields and whatnot to the south, often have birders in there, looking for migrating birds along that. So I thought, well, why can't we make this a green space? And what that took was a vision of development that really was very innovative. And it brought together a group, the City of Columbus, Metro Parks, and Audubon, and then eventually Grange Insurance became a part of this. And they pooled their resources and used the Green Ohio Fund, or the Clean Ohio funds, to basically do pieces at a time to redevelop the area. And let's take a look and see, what's evolved since the early 2000s to now. And it's actually quite a showcase for the City of Columbus. So here's an overview of the Metro Park. You can see the map showing the different features here. So let me go in and actually look at some photographs of some of these features. And you can see, here's the river, and this is why it's called Whittier Peninsula. This is actually a peninsula, into the river itself. And then this is the redeveloped areas. So if you noticed in an earlier photograph, the water tower associated with that Lazarus warehouse is now a bird watching facility. It's not used as a water tower anymore, and it has these platforms that allow for bird watching. There are water features with walkways through them, and this particular water feature encourages people to go in and actually, take off your shoes, roll up your pants, and go in and take a look. And then there are walking paths that go through. And then there are other water features here. And then there's the fitness courses down there where you can, try to flip the large tires as part of your workout, or do the step through the tires here, or crawl over the wood, for a bit of agility, type of fitness activities. And some of the other items, here's a sand volleyball court. There's more obstacle courses on that fitness that I had shown on the earlier slide. There are picnic shelters at multiple locations, which are available through Metro Parks to be reserved, and then lots of walking trails, both along the river and through the areas. And I'll get into a little bit about the engineering controls associated with those. To give you a sense of what has changed, these are some then and now photos. So you can see the small manufacturing facility in the lower left, and you can see what it looks like now with the Columbus downtown in the background. And here's an area, the mowed grass in the foreground. That was part of the impound lot. Here you can see the water tower when it was a part of the old warehouse, and now it's part of the bird watching, and this is actually a rock climbing um, facility there as well. And then here's a view. This was along Whittier Street. You can see the guardrail there, and this is, I believe, where the petroleum storage facility was. It was already gone at that point, and now it's actually part of a water feature that's there. So you can see how it's changed. And this actually has the prairie environment here with the unmowed vegetation that's probably 3, maybe even as high as 4 feet. But this is more to enhance bird activity and wildlife, but it's also part of the remediation approach. Another look at what was there before. This is the impound lot. This was actually where they had folks keeping an eye on the impound lot. So this turret was actually a tower where they ran the gate to let people in and out when they were coming to pick up their cars, and actually trying to stop people from breaking in to take their car back without paying their fines. So you can see this is now an open area, as well as some of that prairie area too, to enhance some of the wildlife. Now, when I was talking about the brownfield remediation approach, I talked about engineering controls, and I want to show you some examples here. You can see the warning on the sign. These wetlands were constructed in conjunction with environmental remediation efforts, and the following covenants are in effect for both humans and pets. No contact, consumption, swimming, fishing, or wading in these wetlands is allowed. So this one, they don't encourage it, and to help not having people go into this water, that's part of the reason why they have this unmowed, somewhat difficult to get through vegetation to kind of dis or prevent people, or not give them an incentive to actually want to go in there and explore. And then this is the floor of the warehouse, and there was contamination below the floor of the warehouse. So the floor of the warehouse stayed in place along with pavement to essentially do what I described in that Lowe's next to the old Crew Stadium. And this is essentially showing the floor and the pavement, which are engineering controls that serve a function. They're parking areas, but they're also protecting the public. And of course, one of the crown jewels of this development is a LEEDS Gold Certified Audubon Center. And this is a building, the public can rent it out. It would be a great place for like receptions and whatnot. It has a nice meeting area here that could be set up for receptions. Actually, I've gone to several convention type meetings there. But it's also the offices for the facility, and for Audubon that has facilities there as well. And this, as I have on the slide, this is a LEEDS Gold certified. So it has, it has your non-painted wood on there. It has the overhangs to shade the windows in the summer, but then allow passive heating from the lower angle of sunshine. It has all of the water features associated with the water runoff, and a retention garden here as well. So there's a lot of really neat, environmentally friendly features built into this facility. So what do you do if you go to Whittier? Well, there's a lot of things to do. I mean, you can go to the Grange Audubon Center, do some bird watching there, look at some of the interactive features. If you have a Boy Scout or Girl Scout troop, I mean, there's facilities there for them to do educational outreach. Bird watching, both at the center and anywhere on the property. Lots of places to go walking. There's a wall climbing. There's the exercise areas. There's also a bark park. I didn't have a photo of that there as well. So if you have a four-legged friend that you want to go ahead and bring along with you, there's a place for that. But primarily, it gives you an opportunity to be in the city, but be outdoors. And I think that's a very valuable consideration. And I'm glad to see that brownfields, that this is actually a more common approach to brownfields in some of the urban areas. So I want to thank you very much. Again, I'm Kevin Spatana with Audubon University and BSI Consulting Services. And I hope you've enjoyed this presentation. And if you have questions, please feel free to get in contact with me.